Welcome to Tech Diet. Today we'll dive into this new problem, minimum operation to make integer 0. It says you are given two integers num1 and num2. In one operation you can choose integer I in the range 0 to 60 and subtract 2 raised to power I plus num2 from num1. Okay, return the integer denoting the minimum number of operations needed to make num1 equal to 0. So let's understand the problem first. So we need to subtract from num1 num2 and some power of 2, that will give us x, right? And then from that x we again subtract num2 and some power of 2, that will give us y. And then from this y we'll again subtract num2 some power of 2, let's say 2 raised to power k, and finally this gives us 0. And so from here we can say y is nothing but the summation of these two. All right, and I can substitute value of this y here. So we'll get rid of this equation. Similarly, x can be written as this with the summation. So x becomes this. Now we can substitute value of x as this. Get rid of this. Num1 can be written as summation of this. Okay, so now this is the final expression. Let's clean it a little. So we have num2 minus num2 minus num2 is equal to sum 2 raised to power I plus 2 raised to power j plus 2 raised to power k. So this is our final expression. So on the left hand side we have three negations, on the right hand side we have three positives. So that's is one operation, right? So that means our equation would be something like number 1 minus our answer, which is our steps, that will be minus num2, and then we'll be having those many 2 raised to power I, 2 raised to power j, 2 raised to power k, until this expression matches. So we need to find the minimum value for this step, right? Okay, so that means we'll have some expression here, right? Let's call it as the difference. So now our question really is, how can we denote a number into powers of 2? So let's take an example of 38. It can be denoted as the nearest power of 2 because we are interested in minimum. 32 plus 4 plus 2, right? Or if we see it in binary, we can say 32 is nothing but fifth place, then at the fourth place, then at the second place. So 38 binary is nothing but 1 0 0 1 0 0 and 1 0. So here if you see, if you want to transform this into, so 38 minus 38 will be 0, so you want to translate this into something like this, right? So that means set all the bits to 0, or we need to say count the number of 1 bits, right? Count the number of 1 bits. So that will be your starting point, the starting number of operations that you might need, and the maximum number of operations to turn a number into this summation would be like if all the bits are 1, right? So that is the maximum number that we have. So let's say, what is the maximum number that we can attain by using this log of 2 for this 38? So it comes out to be 5, right? So that's the max operations that it can have. So our starting number is 3, the number of set bits here, and then 5. So our answer lies in between this 3 and 5. So okay, and let's see the bounds that we have. Num1 can be 10 raised to power 9, num2 can be 10 raised to power 9, and minus 10 raised to power 9, and we have to see the subtraction, so we'll keep this value. So it can go up to 10 raised to power 9 plus, and okay, the number of k is allowed is 60. or whatever the steps that we have. Let's assume it as 60 with the negative 10 raised to power 9. This comes out a whole big value, right? It will be something like 61, then 000 000, something like that. So that is again out of bound range of integer, so might need a long there in Java. And just like we depicted for 38 how many max operations we will have, similarly we can depict how many max operation we'll have throughout our test cases. So the number of max operation that this digit will require is, if you do the math, it will come around I think 35 or 36. So let's start with that. So we have to start with step 1, and we'll say step less than equal to 35, and then step plus plus. Now one thing to notice is like we are doing the difference, right? Let's take an example where num1 is 5 and num2 is 7. So if you do the difference, we'll get 5 minus 7, which is minus 2, and we can't depict anything which is positive summations. There isn't anything. This cannot happen, right? The summation of positive numbers cannot lead to a negative number, so that means num2 should always be less than num1, only then it makes some sense. Or the difference should also be greater than 0. Even 0 can't be depicted as a positive summation because 2 raised to power 0 is still 1, so we can't start with that. And so the difference should also always be greater than 0. That's the condition that we have. So let's calculate the difference. Since the digits are quite long, so we can calculate the distance something like this: num2 multiply by that step. So that's your difference. And if your difference is negative, we know we don't want to proceed. Let's just say continue. And then we want to count the minimum, right? The minimum that could be an answer. So that will be like the number of set bits in this long. So we'll say number of bit count for this difference value, because in our case 38 was difference as an example. So in this case num1 minus step into num2 will be our difference variable. We'll say how many bits are set there. So we'll have, let's say, the set bits, and now we can say okay, the bits should be less than or equal to step, right? So we are at step 1, and if there are more than one bit to nullify, then we can't proceed, right? That can't be our answer. That step can't be our answer. We definitely need at least two bits. So there are two bits to reset, and we just have one step. We can't do it in a single step. So we have a bare minimum of two steps. So this is not a valid scenario. And then we'll have our step should be, or our bits should be, the difference should be greater than the step. It can greater than or equal to our step, right? So imagine like we'll have all the values as 2 raised to power 0, which comes out to be 1, and it can be depicted as the summation of ones, right? That is the maximum that we can go when all the bits are 1 basically. So that will be equal to step, or they we might do some optimization and figure out okay, 2 raised to power 2 can also be replaced by this single 2's, or the other 1 and 1. So in that case this difference will be either more than or greater than the step. So we'll just say we found our step here. That will be the minimum because we are iterating it from the smallest, and then we'll say return -1. Let's just check. We haven't defined an int here. Okay, this works. Let's do a custom test case. We'll pass on some random value. Yep, so yeah, that's the answer. Thank you.